Hey, good morning, everybody. I'm Manoj Jain, a Senior Program Manager with Microsoft's India Development Center. And today, I'll talk to you about Microsoft's cloud-scale disaster recovery solution called Hyper-V Recovery Manager. It's built on top of all the good things in Windows Server 2012 and SCVMM 2012 SP1. In this session, you will learn about the problems that plague disaster recovery solutions as such in today's market. You learn about a new architecture called Disaster Recovery as a Service, DRAAS for short, and then we will go deep into Hyper-V Recovery Manager. Before we get started, any guesses on what this photograph is about? Of course, it's a disaster, but which particular disaster is this about? No, not Katrina. Yeah, I heard Sandy. Yes, this is Hurricane Sandy, the hurricane that wreaked havoc on New York City on 29th October 2012. Lots of damage to human life and property, but it impacted IT as well. And I'll take a couple of real-life examples to elucidate how IT was impacted. Datagram, a well-known hosting provider housed on the 25th floor of 33 Whitehall, Manhattan. Their primary data center was on the 25th floor. You would reckon 25th floor, they would be safe from a hurricane. And they had invested in diesel pump generators to protect against power outage. So when Hurricane Sandy was approaching, they thought they were well protected. When Con Edison, their service power supplier, shut down power, they thought they were well protected against power outage as well. But where were the diesel pump generators? They were in the basement, yes, and basements get flooded. Datagram went down for about 72 hours. Some really super heroic efforts from the employees got them back online in about 3 days. Huffington Post, BuzzFeed, just a couple of names among a lot of well-known names that had business outages. Internap, another well-known example that Sandy took down. The point is, disasters are commonplace. They might vary based on geography, region, or season, but they could happen to anyone. They could happen to you, they could happen to you, they could happen to you, and we all need to care. There could be tornadoes in Oklahoma, there could be floods in Prague, or there could be tsunamis in India. There could even be man-made disasters like terrorist attacks or so on, and we need to care. But do people care? Let's look at what a popular disaster recovery plan out there that businesses deploy. Any guesses on what's a very popular disaster recovery plan? Sorry? Yeah, backup. Someone said none. People probably said SAN replication. But the answer is yes. The most common or popular disaster recovery plan as of today is help, help, help. People consider that they will not be hit by disaster. And if they are, Superman will come from the sky and save them. And we all know that's not going to happen. But why this state of affairs? Primarily two reasons: cost and complexity. The disaster recovery solutions that are out in the market today cost a fortune to acquire, to deploy, and to run. And most times, if not all, they require a PhD to understand all the complex settings that are there, to get it running, to maintain all the agents that are required, to even get it off the ground. Most times we hear people taking more than a week to get off the ground. So the cost and the complexity leads to a state where a lot of workloads which businesses would like to protect are unprotected. People would like to have more of their workloads under a DR so that they can have better business continuity, but they're not able to afford. Therefore, only the large enterprises and within them the mission critical applications are the one that gets disaster recovery. And people hope someday they'll have the budget. But So to change this landscape, Microsoft embarked on what we call a DR journey. And the mission was democratize DR. We wanted to democratize DR, make it available for all businesses, for all workloads. And we took the first step in that with Hyper-V Replica 2012, a DR platform that shipped with Windows Server 2012. And in this year, we're doing a two-pronged investment. We're improving on Hyper-V Replica with certain of the gaps being addressed, and then we are introducing Hyper-V Recovery Manager. I'll drill down briefly into Hyper-V Replica, and then we will go into Hyper-V Recovery Manager. So Hyper-V Replica 2012, it was built on 4 strong pillars. It was in-box. It was inside Windows Server 2012. So no extra cost of acquisition. You did not have to put things from different vendors and put it together to make it work. Since it was inside Windows, it worked really well with the Windows ecosystem. Tight integration with clustering, worked very well across migrations. You did not have to manually redo replication setup. And it had all the required DR scenarios. So it had test failover for your testing, for your drills. It had planned failover for your planned maintenance, for your compliance needs, etc. And then it had unplanned failover for your disasters. Plus, it was application and storage agnostic. So with that, again, it brought the cost down significantly. Being storage agnostic, you could have heterogeneous storage on the 2 sides. Therefore, you did not have to invest in the expensive SAN hardware and the related software for replication and protection. It was application agnostic, therefore you did not have to train your personnel in different types of application replication software. And therefore people could easily deploy this for a lot of applications. This was the value prop that it delivered. What was the response from customers? Phenomenal. Folks just loved the affordability, the simplicity, and the flexibility that Hyper-V Replica offered them. And these are some of the quotes we had actually directly from the customers. So Hyper-V Replica started this journey, and then we're going to Hyper-V Replica 2012 R2 is releasing this year. I have my esteemed colleague here, Raghavendra Gururajan. Guru, can you raise your hand, Guru? He has a session today, later in the afternoon, where he will cover Hyper-V Replica more in depth and also talk about the investments in 2012 R2. I would strongly encourage all of you to attend that session to understand the platform on which Hyper-V Recovery Manager is built. Moving on to Hyper-V Recovery Manager next. So my team and I sat down and figured out, looked at the landscape and said, what are the design principles on which we wanted to build a real world-class cloud-scale DR? And we settled on 4 principles. Simple, as measured by 3 tenets. It should not require you a PhD to get this going. You should be able to get up and running within a few hours, not the 2 weeks that it takes today. Few hours. Third, and important one, every time you need to make a change, you do not have to relearn the entire damn system. You just should be able to maneuver your way easily. There is no ramp up every single time you're making a change. With that, we said that that's how we will measure our simplicity of this product, and it has to be simple. The key word in all these 4 design principles, if I were to take the one that we will really, really vouch for, is simplicity. We do not want you to invest in a DR solution for your DR solution. Therefore, it has to be, yes, it has to be up 24/7. It has to be reliable. When you need it, you want your insurance to pay up. We also understand that different applications have very different RPO needs, recovery point objective, the amount of data loss you're willing to manage. And that can be met by different technologies. Therefore, we said ground up, we will invest in an extensible architecture that will help other technology providers or other technologies to plug in and provide replication, and we will manage and orchestrate the same. Last but not the least, hybrid IT is here to stay. People will have investments in private cloud, public cloud, and hosted/partner clouds. We promise to give you a consistent experience independent of the target cloud that you are protecting into. We also give you consistent user experiences across all the services that you will consume, and I will show you how in a bit. With that design principles as the context, we took a look at these two boxes. These are representative of a private cloud, a primary side private cloud, and a secondary side private cloud built on Microsoft's private cloud stack. SCVMM 2012 SP1 or higher, and Windows Server 2012. So we have private clouds on both sides, and we said, we need to protect between these two. What's the best way? Now, the 4 design principles had some interplay and some kind of a conflict between them. For example, whenever we talk about reliability, most traditional software have built-in layers to bring in reliability, and that kind of takes away from simplicity. Therefore, there was that bit of a conflict, and we'll try to see how we resolve that. And then whenever you get in extensibility, it causes divergence. You're trying to support a varied sort of scenarios, and that could cause divergence. But we said, no, consistency will rule. We will give you all the power, but consistency will rule. With those design principles and this, we said, with the traditional DR software, the number one complexity has been deployment, the agents, maintaining all that, managing all that, ensuring security and compliance. Therefore, we came up, and my team and I came up with this design where Windows Azure Hyper-V Recovery Manager, HRM for short. This is a cloud-based DR orchestration, management/orchestration service. This is available to you through the Windows Azure Management Portal, and I'll demo this in depth today. And at the bottom, you will notice we have an extensible data channel. I talked to you about extensibility, where different applications require different technologies. Right now, we are delivering Hyper-V Replica, but in the future, we will add support for other technologies. Notice that the data always flows from your primary to your secondary. Let me reiterate that. The data always flows from your primary to your secondary. The data never flows to Azure. That takes care of your application, confidentiality of your application data. Only metadata is flowing for the DR orchestration. The 2 arrows that are going into Windows Azure, that's just metadata. And within that also, you could restrict which metadata you want to push up for orchestration. This should address some of the concerns around Windows Azure. Since the data is always going on your channel, your confidentiality is maintained. Any questions before I proceed? Okay. So, along with the application data confidentiality, we've invested heavily in security. SCVMM is the only component that talks to Windows Azure. Windows Azure never makes an incoming connection to your data center. It's always outgoing. It is done on HTTPS, and therefore your standard firewall rules apply. Plus, the entire data is encrypted. We also support proxies. Therefore, again, all your security concerns about none of your Hyper-V Replica host need to change for this. No change to your Hyper-V Replica host. They do not have to be on the internet. Only your SCVMM has to be able to talk to Azure, and that too, it could be behind a proxy. So we have invested heavily in making sure it's secure. Okay, a quick show of hands. How many folks in the room have 2 sites that they want to manage for disaster recovery? As expected, a lot of them. How many have 3? Okay, it's a good number. How many have 4? Okay, I see about 5 people. Anyone with a 5 plus? Oh, wow. Okay. Okay. That's a big number. So considering that, we looked at most DR solutions offer you a peer-to-peer view. You need to have multiple views to manage all the 5 plus or the 4 or even the 3. They do not give you a way to manage all your sites from a single place. But with the cloud-based DR service, we are able to do that. We're able to manage, I'm showing 3, but this could be 100. This could be any number. Any number of sites can be managed from a single place, a single console. This is the power of Windows Azure Hyper-V Recovery Manager. A question that might be running in a lot of minds here, why DRaaS? Why the cloud service? There are 6 main reasons why we did that, and I'll talk to you about each of them. First, no PhDs. We want to make it really simple. With this delivery, and I'll show you how, we're able to take out the number 1 reason why people are help, deployment complexity. We are taking out the deployment complexity through the cloud-based delivery, taking out the agent maintenance, all that, reducing all the complexity that deployment has today by making it simple. No matter what your scale, be it 10, be it 100, be it 1,000, we will scale since it's a cloud design. We will work for all the scales that you could potentially have. And since it's based on Azure, it's reliable up 24/7. The third one, it's my personal favorite. I own the user experience. It's a personal favorite where we are able to actually give you what I talked about, a single console to manage varied scenarios or topologies. You could be going from New York to Chicago. You could be going from Chicago for some other workloads to Boston, or you could be having separate places where you are doing your New York and Boston and some other sites maybe in Europe or China, and all that can be managed from a single console. My favorite. Third one, I talked about it briefly. We said that independent of what your target cloud is, we will give you a consistent experience. It will always remain the same. As it happens, you're away on a vacation to Hawaii, and your CTO calls and says, oh, tornado has struck, we need to implement the DR plan. And you are sweating. No need to sweat. Take out your Surface and log into Azure and start your DR plan. It is truly accessible from anywhere. You can go on your vacations without worrying. Disasters are getting innovative in a macabre way. They're happening in very, especially even man-made disasters. Things are happening in a very weird manner. Things which we hitherto didn't think of. At the same time, complexity of deployments is increasing significantly. For both these two things, DR has to keep pace. And with a service approach, we are able to get you all the innovations faster in your hands so that you can protect your workloads. These are the reasons why Microsoft believes DRaaS is the right way to solve the challenges that DR landscape today has. Let's look a lot of context set. Now let's get into some of the cool stuff we have built. Let's look at the stages that we think are in protection and recovery. So you've done your capacity planning, you've done all the planning, you required hardware, and then you'd go do your setup. We have 2 steps here. You just need to get started, acquire an Azure subscription as a certificate. Then you register your VMMs into Azure. Post that, you map your compute on both sides. You have compute on the primary, you have compute on the recovery, map them. You do the same for network. And followed by what we call enable protection. You actually start protecting the virtual machines. And then you could create a recovery plan, a key component of our product, recovery plan, which is an orchestrated workflow for recovering your workloads. And The most long-standing operation that is in a DR is monitoring, ensuring things are up, ensuring your jobs that you trigger are going on fine, ensuring that the resources that you have, the virtual machines, the clouds, the networks, all are up. So we've invested heavily in monitoring. And then, of course, recovery. Hyper-V Replica built 3 ways to recover: a test failover, a planned failover, and unplanned failover. And Hyper-V Recovery Manager delivers all 3. Let's look into, so I'm going to log into my other machine. Just 1 second. This is Hyper-V Recovery Manager's landing page. So I have created here what we call a vault. A vault is a unit of isolation. You create a vault. Let's assume that you have data centers in US and in China, and due to regulatory requirements, you cannot have the metadata going into from China into the US vault. Therefore, you say, I'll create a separate vault for China or even for Europe. The way you do that is go into Data Services, Recovery Services, choose the Hyper-V Recovery Manager vault, and do a create on this. So for example, here I could say I'll create a China DR. Currently, this is in preview, so we do not support all the data centers. So right now, I'm going to choose West US itself. In most cases, you would have chosen a region in China, and that's it. Your vault is created. With this vault that you created right now, what we do is, I have a newly created vault right before the demo. I'll go into that for Europe. There is a quick start screen which tells you about all the steps, the 5 simple steps you need to take to get your disaster recovery done. You need to upload a certificate and then download one agent. There's only one agent that needs to be downloaded and installed on VMM. All the Hyper-V Replica hosts do not require agents. I repeat, all the Hyper-V Replica hosts do not require an agent. Only the VMM requires an agent. Therefore, agent maintenance becomes easier, security is taken care of. Reduced patching. And then, so you download this. Okay, I'm going to skip that. You download this, and post that, you register the VMM servers. The register is a very simple 3-step process. I'm not going to demo that for now because there's a lot of other things that I want to show. And once you've downloaded and registered, post setup, let's assume Contoso is an enterprise here. Post setup, they have a New York site and a Chicago site. On the New York site, they have 2 clouds, a gold and a primary, a gold and a silver, both primary clouds. And on the Chicago, they have the corresponding gold and silver recovery clouds. And they would like to protect the gold cloud to the gold recovery and silver cloud to the silver recovery. So the first aspect, compute mapping, and the challenges are listed here. There are a huge number of hosts that you need to manage. They could be hosts, standalone hosts or clusters, and the number of settings that need to change. For example, you need to change firewalls, you need to change the ports, you need to maybe install a certificate, change Hyper-V Replica settings. All these needs to happen. Today, without Hyper-V Recovery Manager, all that would have been manual. Plus, of course, you need to do agent maintenance and ensure security. So let's look at how we do configure at cloud scale. So I'm going to go to a vault that I created, where I have registered my two VMM servers, connecting the VMM servers. So while that comes up, I have a US DR vault in which I have two servers registered. So they are listed in the resources. So we have 5 tabs at the top, a dashboard tab that gives you a quick view of your usage and any events that you need to attend to. Then we have protected items, which are your clouds on VMM being shown as the ones that have been configured for protection. Then we have recovery plans where you create orchestrated workflows for your applications. Then we have resources which are the on-prem resources, where you have two types of on-prem resources that we manage. Networks, I'm going to demo that soon. And then you have servers. It shows me that I have 2 servers registered, a VMM New York and a VMM Chicago, and both are connected. And then we have jobs, which is the monitoring place where it shows all the jobs that you have run, and you could query, of course, do a query to filter out and take reports for your compliance. So let's look at Cloud Configure. I have already protected gold primary by gold recovery. So the first row is showing that it's a gold primary, which is of VMM New York, and it is protected by the gold recovery, which is in VMM Chicago. I'm going to go ahead and protect the other cloud, the silver primary cloud. So when I drill down, this is called drilling down in Azure parlance. When you drill down into the silver primary cloud, there are 2 tabs you will see, a virtual machines at the top and a configure. Virtual machines are the list of virtual machines that are already protected. Since I have not configured and not protected any virtual machines, it's telling me that I need to configure protection settings. So I go to configure. Here we have used what is called a progressive disclosure paradigm. We expose you to the complexity that is needed and make decisions one at a time. Therefore, first you choose only one input, which is your target location. Since I'm going to go to VMM Chicago, I'll choose that. And then it asks me to choose the target cloud that I want to protect this cloud by. Here, I choose Silver Recovery Cloud. And then the rest, yes, if I were to choose a cloud that is wrong or it's already paired, a cloud can be paired, or cloud can be configured to be protected by only another cloud. So if I were to choose a cloud that is already configured, it will give me a clear message there, an error message. Okay. The rest of the settings are the familiar settings of Hyper-V Replica. Whether you want additional recovery points, right now it's been disabled, but we're adding support to ensure you can do additional recovery points, and how frequently you want to take VSS snapshots. Plus, we support both the methods of sending your initial replication, IR, either over the network or offline. And you could choose to start the replication immediately or later. I'll choose to go off business hours and click Save. It asks me to confirm the settings, since this is one of the heaviest workflow that we do for you, and I go ahead and say yes. And it's now configuring the cloud. What happens during the configuring of the cloud? Let me show that. So what looked like a 3-click? I chose the VMM, I chose the cloud, and I just said save. I changed the time when IR initial replication would happen. What's happening in the background now? Here I am displaying the gold cloud that I've already protected, and how on the left side, on the New York side, I have an SMB backing the clusters and the standalone host. They're differentiated by color. On the Chicago side, I have a CSV. Hyper-V Replica is storage agnostic, and we give all the goodness in the solution. Now, when you turn on Cloud Configure, it does the following. It installs certificates on all the nodes in the cloud. It did the same now on the primary. Since it is in the cloud, it can do all this parallelly and get you off the ground really fast. After that, it takes care of your firewall rules on all the nodes again in the cloud. Then it does your HVR, Hyper-V Replica settings. Hyper-V Replica settings require two steps. One is installing what we call a Hyper-V Replica broker on a cluster. In certain configurations, we actually set up the broker automatically for you so that you do not have to go to each cluster in your cloud and configure that. And then we turn on Hyper-V Replica settings across all, both the standalone and the cluster nodes. The same thing on the New York site. I'm showing this that it can happen asynchronously, can happen in any order, they can happen parallelly as well. Now, so once we set up, let's assume that later you added another host to enhance the capacity on either side. We monitor for environment changes in your data center. We look for changes that require triggering a workflow, and we set that up automatically. Should you change the environment, adding networks, hosts, we take the required action proactively to ensure replication continues, and you do not have to go do manual setup anywhere, taking out the number one complexity of deployment. With that, what I have done is I have been able to configure the compute on two sides at a cloud scale. All my hosts are configured, the agent that is required is set up, including the Hyper-V Replica settings, all have been set up with this. My compute is mapped now. Now I can go ahead and do enable DR. So with that, I have my VMM New York and a VMM Chicago. The New York has, like I mentioned, a gold and a silver primary cloud. I have an unprotected VM here. My rest of my sales and marketing VMs are already protected for the demo purposes. I have an unprotected VM here. Now to protect it, all that is needed is a single click. That's okay. Yes. So during the placement, we also ensure that highly available virtual machines are placed on highly available host on the recovery side. We also ensure that all the networks that are required for the virtual machine are correctly set up. So in this case, since I had a cloud, I had a VM that is highly available, and on the other cloud I did not have any host that was clustered, it gave me an error. Sorry about this. The VPN is a bit flaky today. So in that case, what would have happened is I would have clicked on enable DR and the VM would have been protected. No additional settings required during enabling recovery on a VM. All you need to do is check that button and enable recovery happens. No additional settings required. You do not have to, all the settings are now at the cloud level. It's been really simplified. You do not have to deal with, oh, this VM is at a different setting, this VM is at different settings. Since the cloud is an SLA, all the settings are the same and it just works. You just have to click on enable DR. And the rest of the VMs are already protected. So With that, we took care of, I won't be able to show the enable DR because I made this highly available and I do not have the same on the other side. Okay, with that, compute mapping is out of the way. We need to do network mapping. This is far more complex because the number of networks is far higher than the number of clouds that you have. And it will scale, it will multiply by the number of virtual machines that you have. Each virtual machine could be attached to multiple networks. So your worries would be, I have just too many virtual machine networks. I have a mix of static and dynamic. Do you work in that? Do I have to actually go and do settings on each VM, or is that taken care of automatically? Does it work with Hyper-V network virtualization? Multi-tenanted works really well with Hyper-V network virtualization. Do you work the same? Let's look at how we solve this problem. Before going there, pictorially, let me represent the same problem pictorially. I have now protected the gold cloud and the gold recovery. I have two networks on the primary side, a network sales and a network marketing. Similarly, on the recovery side, I have network marketing recovery and a network sales recovery. I have a marketing VM for which I have already enabled recovery. Therefore, the replica VM is created on the gold cloud recovery. And I have another sales VM which I have not turned on replication for. So what should happen in this particular picture is that red VM on the right side needs to get protected and connected to the network marketing recovery. You do not want to go and do this manually. How does the solution help solve this problem? So I go back, I go to the resources, and I go to the networks. In the networks, I choose, so I'm doing network mapping from VMM New York to VMM Chicago. Therefore, I choose New York as my source location and my target location as Chicago. It shows me the list of virtual VM networks that I have. For example, it shows me the list of virtual VM networks that I have. I have already mapped infra, and I have the other two unmapped. I choose the marketing one, and I choose to map. It helps me figure out the target network that I want to by giving me in details of what the network setup is on the on-premise. It tells me what the subnet is and which type of network I have set up. I could choose network marketing recovery. Let's assume I didn't remember which network to choose, and I chose a network infra recovery. It will show me that this is not the best choice by showing me the clouds that network marketing is attached to and whether network infra recovery is attached to the cloud that it is protecting. So what this is doing is now getting the four-way relationship: cloud to network, cloud to cloud, and cloud to network here. So there's a four-way relationship here. The cloud on the primary is attached to the network. The cloud on the recovery is attached to the network. Those are the two relationships. Now the cloud has been attached to this cloud. That's the third relationship. Now the networks have to be attached to ensure that it works. And it tells me that this is not available to the gold primary, to the gold recovery cloud. I'm not able to show this, but it will show you, it will give you more detail about that if you chose this network, when the virtual machines fail over, they will not be connected to the right networks. So you might have failed over the virtual machines, but for business continuity to actually work, you need to be able to access the VMs. The VMs need to be able to access each other. Clients have to be able to access the VMs. Therefore, the VMs have to be attached to the right VM networks when the failover happens. So I'm going to go ahead and choose network marketing recovery. And with that, all the background work, again, we do all the heavy lifting of figuring out which virtual machines are using the network marketing, take their replica machine, so take the replicas and attach it to the replica VMs. Okay, there's an error. So this tells me that the operation has started for mapping the networks. We'll come back and look at this, but let me show you what's happening at the background. Oops, sorry. So what's happening is, this is the side that I showed before. Now I did this network mapping between marketing and marketing recovery, between sales and sales recovery. What happens with that is the VM is automatically connected to the network. You do not have to go to each VM and configure the VM networks. They're automatically connected. And in case I enable recovery for a new VM, it is created, the replica VM is created with the right VM networks attached. During placement of this VM on the cloud, we also ensure that the network sales recovery is available to the host, and therefore we place it only on host to where the network sales recovery is. And therefore the smart placement helps you ensuring that the network is always accessible to the VM. We work well with Hyper-V network virtualization. This is a familiar site where we have used Hyper-V network virtualization, HNV for short, between two sites to achieve customers having their own address, bringing their own address while having different provider address, and we work well in this case. The way it will happen is, if your CA address that is on the replica on the primary is taken to the replica side, and we use the same customer address on the replica side. Therefore, that is also automatically taken care of. Another thing to note, your source and your target can actually be heterogeneous. On New York, you could have VLAN, and on Chicago, you could actually be using HNV or the vice versa. We work in all these topologies. Like I mentioned already, the replica VMs are connected. And if you had an IP pool defined on the secondary side, we reserve an IP, pull out the IP, and insert it into the VM. All that is taken care of with network mapping. Okay, so we've done compute, we have done network, and we have enabled certain DR. Now, give me single click failover. That's a simple ask people have. Let's see how that works. So I'm going to go to the recovery plans. I'm going to choose a sales application DR plan. I have created two DR plans, one for my sales application and one for my marketing application. I'm going to do failover and choose planned failover. This is in case I have planned maintenance, or I know of an impending disaster, or for compliance. It tells me, it gives me the direction in which the failover will happen. Therefore, again, sitting in the cloud, you're able to failover from New York to Chicago, and in a symmetric manner back from Chicago to New York. It also allows me to choose whether I want reverse application to happen as soon as my planned failover completes. There are scenarios where you do not want reverse application to start. Once you start, so reverse application is, I was protecting from New York to Chicago, I failed over from New York to Chicago, and now Chicago has to get protected back to New York. That's what we call reverse application. There are places where you do not want to do that. Two main reasons is you want to complete some testing on the other side before starting the replication, so that you do not, in case of some corruption or certain issues, you do not want to send the corruption back. Also, your primary might be down for longer. You do not want the replication to start throwing errors. So you could choose to actually disable reverse application, which is what I'm going to do now. and start the DR. Now what this is doing is it is starting a planned failover of my entire application. With one single click, I have actually been able to take a complex DR and a complex sales application and fail it over. It's sorry? Thank you. So, oops, 1 second, let me see this. So if you notice, the sales web tier and others were running on New York. They're getting stopped now slowly, and they'll start moving over to the Chicago site. I'll come back to display this. This will take a few minutes to complete, since it has to orchestrate, make sure everything is done. We'll come back to notice that it will actually start running on the other site in a minute. With that, single click failover has been made easy. You actually can achieve what people have been always, what used to be mythical, that I get a single red button and I can go and click single click failover. How did we get there? Let's look at how protect happens. We all know that we have dependencies between workflows in the data center. They have to fail over in a particular order. You also want to do all the cool stuff with PowerShell so that you bring down the RTO, recovery time objective, and bring your business up faster. We also know that all the things cannot be PowerShelled. There are certain things that have to be manual, like turning on the coolers. So how can all this be achieved? Let's look at what we call recovery plan authoring. I'm going to switch over back to my demo. And if you notice right now, the sales middle tier is also stopped. It's going to go to the DB tier. The shutdown happens in the reverse order of the way the startup happens. So right now, it is shutting down. So going back to my recovery plans tab, I'm going to create a recovery plan. Let's call it TechEd North America demo. I'm going to say I want to go from New York to Chicago. It shows me all the virtual machines that are currently protected between the two sites. I could choose the ones that I want to set up for the recovery plan. So in this case, I'm going to set up one for marketing. That's it. With this, I've actually created a recovery plan with which I can fail over the marketing app. But that's not enough. You need to model dependencies. So if for people who have a very simple workflow where you want to fail over a bunch of VMs together with no dependencies, it stops here. Simple. You don't need to worry about the rest of the dependencies, the scripting, and others. But for those apps that actually do require, so basically there's a continuum we have of just simple single group failover, or you could move them into different groups. So this is what we call the recovery plan authoring screen, where the first step is all the groups shut down. Like I said, it happens in the reverse order of how it starts. And then we have a group. So when you create a recovery plan, all the virtual machines are added to a default group called group 1. You could create more groups. So I'm going to create a new group. A new group has been created, and I will select my web tier and say move the virtual machine to group 2. What I have done with this is created sequence groups. Group 1 fails over first. All the virtual machines in group 1 will fail over first. After they are all successfully failed over, group 2 starts. It doesn't stop there. We could say I need to do between these two groups, I want to check that the DB tier came up. So you could add a script before the failover of group 1. The script, you can give it a name, check DB tier, and give the path, say maybe run as .ps1. What we are doing here is introducing a step in the workflow execution that will actually execute a script residing on your VMM. So, for example, I have actually created certain scripts here. You need to create the scripts out in your library on the VMM. I have created some scripts, like for example, run as, take backup, update DNS. Sort of some of the popular things that people want to do during disaster recovery. For example, if the disaster recovery has happened and you failed over, you probably want to start taking backups there. So what I'm doing now is I'm choosing the run as script and going to add it. It creates a separate group called group 2 pre-failover steps. Since I added a step before group 2, it's created a group 2 pre-failover steps, and I could add more steps to it. For example, I could add another script. I could add a manual action. I'm not going to do that, but I could add, let's assume that before I start the VMs on the other side, I want to turn on coolers. So I would say add after all groups have shut down on the primary side, turn on coolers. And I can give instructions for myself, saying what I need to do. I can make it as clear as possible, give IP addresses, machine names, etc. And it has added a manual action. Now, what this manual action does is, while executing, the execution stops for you to take your manual action. Once you have taken your manual action, you go and indicate in the job view that you have completed the manual action, and then execution will trigger. It waits for your inputs that you have completed the manual action. So with this, I have created now a recovery plan where I have turned on the coolers and I have two groups in which I will fail over. All this done within 3 minutes. I have actually created now a recovery plan for my marketing app. When I do a failover of this, it will do it in this order of your DB tier followed by my web tier. It will make sure that it runs the script. It will wait for me to turn on the coolers before actually doing the execution. And it has created a demo recovery plan, which is between the source and the target of New York and Chicago. That's how we arrived to the state where we actually did a planned failover. And if you notice now, the sales, web tier, the middle tier, and the DB tier have actually stopped on VMM New York. Let's look where the progress is, and they are running on the Chicago site. All orchestrated from a single place. We stopped the VMs on the New York site, and we actually started running them on the Chicago site with ordering taken care of. That's how we get to single click failover. Okay, so with this we were able to do a shutdown, we gave sequence groups, we gave extensible orchestration where you could add scripts or manual action. That's what the recovery plan delivers. Okay, people say that we want to test these things, but we do not want a business continuity solution to impact business continuity. When we are testing, we don't want it to go down. We also require frequent drills so that I can submit them for audit, the reports, and also use that to track how much RTO I'm taking and shave off minutes from that. Plus, most of the time you use this to get your personnel to understand the various roles that are there. Therefore, testing is the best way to train them when a disaster should happen as to what they need to do. Let me show how a test DR happens again. Now the all familiar recovery plan. I choose the marketing DR plan that I had created, and actually let's look at the previous recovery, the planned failover that we had done before we go to the DR drill. So it is showing that it has completed the DR drill, the planned failover of the sales app. All the groups are completed and the script failed for some reason, but it completes. So this was the previous planned failover that I started about 10 minutes back, that completed and moved VMs over. And it gives me a view of the jobs view, gives me a detail of all the tasks that were run, along with when it started and how long each one took. So for example, if you find that any of your tasks are taking longer and impacting RTO, you could consider scripting some of it, and therefore bring down the RTO so that it meets your business needs. Okay, moving back to the fire drill, to the drill that we talked about, the DR drill. I could select the marketing plan, and all I need to give as an input is a logical network. Again, I specify a logical network and say in which direction I am planning to do the test failover. In this case, I'll choose the TFO logical network and do OK. It has now triggered a test failover for me. What happens in a test failover? Let me show you that. This is the familiar screen we had when we completed the network mapping. We had the cloud mapped, we had the networks mapped, therefore the VMs were connected. Let's assume that I am using, right now the focus is now on the recovery side, so therefore we move that into the focus. Let's assume that I have a customer address pool which is 10.0.0.1 and I triggered test failover. What does test failover do? It creates a test environment that you would have had to manually do it today without this solution. It figures out all the virtual machines that are participating in the recovery plan and finds out all the VM networks that they are attached to and automatically create those virtual machine networks with using the same CA pool. So Hyper-V network virtualization is being leveraged in your test failover, and it creates a VM for you. A test VM is created, a test network is created, and they are attached. Post this, you could run your tests against this, and once you're done, you say I am completed. What it will do is it will clean up the test VM, it will clean up the network, and it will clean up the entire test network environment. Absolutely no remnants of your testing done. All you did was one click, tested your applications, you said I completed my testing, and it brings you back to this state. Okay. So with the DR drills, like I mentioned, your VM networks were automatically created. For the Hyper-V network virtualizations, we actually carried forward the settings and ensured that they worked. So yes, DR drills will become intense once Hyper-V Recovery Manager is available. DR should be by design and not by default. For that, testing this periodically will ensure you have everything in readiness for your drills. Let me check if how far the test failover has progressed. These are the so while that comes up, these are the things that we went through today. We saw cloud mapping, network mapping. We saw how recovery plans are created. And then we actually checked how jobs and resources are monitored, and we did a DR drill. Let's complete the DR drill quickly. So this is indicating to me that the DR drill is whatever the system had to do, which was to create the networks, the machines, create the networks, attach them, do a failover of the group 1. Everything is completed, and now I can say complete test failover. I indicate that the test failover is complete. I also could run some client tests. Ran client tests, all is good. And all this is recorded for my later verification or for my audit, saying that here is what all I did during test failover. I could actually give more details of all the tests that I ran, and all that will be stored in the observation. And now it will complete the test failover, it will clean up the virtual machines. So with this, we just actually completed a full fire drill. So we saw these stages. We went through the stages of setup, configure, protect, monitor, and recover. With coming in closing, what is the value prop of Hyper-V Recovery Manager? We automate the replication, and we give you an orchestrated recovery. We also continuously monitor all the virtual machines, and based on environment changes, make sure corresponding workflows are triggered. And this is why you should choose Hyper-V Recovery Manager. It's simple, it is reliable, it is extensible, and it is consistent with the rest of the Azure services that you are using. It takes out-of-the-box features like Hyper-V Replica and Hyper-V Network Virtualizations and delivers into a simple recovery solution. With that, there are more things that I could cover, but I'll close here and invite Guru to show a demo of the Hawaii. So I talked to you about this briefly. I said one of the reasons we did a DRAAS, it's actually accessible from anywhere. I do not have a surface here, so I'm using a phone to trigger it. Where right now in this phone is actually logged into the same place we are logged in on the USDR, and I am now at the recovery plans, showing me the recovery plans view. What I will do to close is choose the new recovery plan that we created. And actually, the single red button made easy. Sitting in Hawaii, I could click a failover. Yes, that's a good question. Thank you, everybody. Yep, I'll take questions now. Yes.
You demo where the primary site's still up and it's shutting down. What happens if you lose your primary site? Can you do the failover without having to contact the primary site?
Yes. So, sorry? Yeah. So the question was, in case the primary, we showed a demo where the planned failover was happening where the primary was still up, and what if the primary was not available? The answer is yes. In case of a primary down, you would trigger the unplanned failover. What I just triggered right now, the TINA demo, I just did an unplanned failover because the disaster has struck, my primary is down. It will not try to contact the primary and it will just work on the recovery site. It will do that. Yes, question.
The certificate that needs to be installed in Azure, is it a public certificate? If so, can it be a wildcard certificate for the domain?
So the question is the certificate that's installed, is it a public certificate and is it okay to use a wildcard certificate? Yes, so you need to upload only the public part of it, not the private part, and you could use wildcards if you needed to, but we would recommend you use more secure than a wildcard. is a question. Yes.
You showed in orchestrators that you were using scripts to do certain tasks.
Yes.
Can I read output of the scripts and make decision based on like if script found something during that running it?
So is the question about can I use the output of a script to do something?
Yes.
It's a great question. So since this is scripted and we orchestrate the script, the failover, if you could have another script on top of your current script and based on the output do anything else. Currently, we do not take the output of the scripts into the service and take actions based on that. But in your own scripts, you could decide to do something differently. What's the scenario you are looking for doing this?
Let's say I found that application did not start, and at this point I want to stop my orchestrator and require manual action before I continue.
Right. Currently, so good question. So in case of a planned failover, if the script fails, we stop execution. Since it is a planned activity, with any failure, we stop because we think something is wrong, you want to attend to it. In case it's an unplanned failover, we continue. Because in case of a disaster, recovery happens in iterations. You take 3 or 4 iterations to actually get, and you could repeat the unplanned failover multiple times. It's idempotent. But if it's a planned failover, a script fails, we stop execution so that you could fix it and rerun it.
So how I make my script fail? I mean, is there an output? Like
yes, we look at the output of the script based on the error code that it returns. Based on that, we do this thing. It's a good question. Thank you.
I have a question for you.
Yes.
And this may be something you already covered. But if let's say you're doing a planned failover, and you fell over, and then you're ready to fail back.
Yes.
Does it have to resync the entire server, the entire virtual machines back over to the primary site?
Okay. So the question is, in case I did a planned failover, and when I want to come back, do I do a resync? So in case you have turned on enable reverse replication, the replication is continuous, you can just fail back immediately. But in case you disabled replication and you had accumulated a lot of logs on the recovery site, on the Chicago site, during a failover, it will do a resync. It depends on how much churn you have accumulated on the other site, which will decide whether you do a resync.
Okay, so it just replicates just the changes, not the entire VM again?
Absolutely not. So in case you have enabled reverse replication, it just sends the delta. If you did not, and whenever you turn on reverse replication, it will do only the change. So what resync does is it matches the change blocks on both sides and sends only the changes across.
Cool, okay.
Yeah.
Awesome, thanks.
Okay, thank you.
During testing of failover plans and whatnot, you said you're using network virtualization. Is there any ability to use a physical network in case I've got a customer that's got like a mainframe and they need to be able to, they've got like extra interfaces on that and they need to be able to test it against the mainframe. If they're using network virtualization, it's going to be kind of hard to do that.
So the question is, can I work with just physical networks?
For the actual testing to make that make like an isolated network on like a separate VLAN or something like that.
Right. So since this is based on the SCVMM, we require you to have logical networks which will map to the physical networks, and then we will create the VM networks. It can be VLAN based. It did not have to be HNV based.
Okay, so that would be possible.
Yes, it is possible. Maybe I didn't talk about it. You could use VLAN based. It's not only HNV based. We support all the network topologies. I just gave an example of Hyper-V network virtualization, but we do work with VLANs very well.
And one final question, is there any things on the roadmap to integrate with storage replication so you can do like consistency groups with VMs and that kind of thing?
Sorry, which replication integrate with?
Storage-based replication, that you can orchestrate the storage-based replication so that you could do like consistency groups with VMs.
Like for example, SAN replication or so
Yeah.
on? Yes. So the question is, can we do other replication types? Since I mentioned we have an extensible channel, we could, right now it's only for Hyper-V Replica, but it's pretty straightforward for us to start integrating other providers like SAN or even SQL or so on. Today, in fact, with the scripting method, you could have a VM backed by a physical SQL, and you could fail the physical SQL using a script, which does, if you're using always on, you could fail the SQL using a script and then fail over your VM. That's possible. But yes, we do intend to add in the future other providers.
Thank you.
Thank you.
I guess it's just a double question. So, does that support, I mean, the recovery plan supports only PowerShell scripts, and is it integrated with Orchestrator?
It's a great question. So the question is, does it support only PowerShell scripts, or is there plans to integrate Orchestrator? The answer is twofold. First, we support only scripts currently, but you could always put your runbooks inside the script and use the script to trigger the runbook. The second answer is my last point in my DRAAS slide. A service-based approach helps us get innovations faster to market. So we do have orchestration integration in the backlog, and the list of things that we are tracking, and we will deliver to you. Thank you.
Is there any plan to have Azure be the actual DR target?
So the question is, will Azure be a DR target? The answer again is the twofold, second being the same as the previous answer, where we can get innovations faster to you. But the first answer is, we have heard feedback that people would like to do enterprise to Azure, and again, we have that in the backlog. We are tracking that. We've heard significant feedback around the same. Okay. Thank you, everybody.